Okay, this is the quick video I promised you from the 2A1 only part of the notes packet I gave you today. We're going to talk about per capita and scaling. Capita just means per person. So anytime you're doing a problem where it says how many such and such per person, you're doing a per capita problem. Or if they say per capita, that also is a per capita problem. So Antonio and Juliet are opening a new business. They decide to send informational packets to relevant businesses in the extended community. They are including three things in each packet and creating 400 packets total. If there are five people creating the packets for distribution, what is the number of packets per capita? So that's per person. Well, the three things in each packet doesn't really matter because we know the total number of packets. So total number of packets is 400. The total number of people making them was five. 400 divided by 5 means that each person will make 80 packets. So that would be 80 packets per person or per capita. Okay, let's look at another one. A third grade classroom consists of 24 students and one teacher, so that's 25 people total. One of the students will bring in individually packaged candies to share with the class and the teacher. So they're sharing it with all 25 people. Okay. And they're doing that to celebrate their birthday. They're going to bring 150 pieces of candy for everyone to share. If everyone receives the same number of candies, find the number of pieces of candy per, that's what we're dividing by, capita, which means person. So we have 150 candies divided by 25 total people. And if you divide that on your calculator, you should get that that's 6 candies per person. Okay. Now, this one is thrown in just in case you get one of these in your homework. Sometimes in the per capita section, when I played through the homework myself, every once in a while I'd get one that's not per capita. And the way I know that is that it'll say per something else. So this says the city of Tourist has 298 hotels with a population of 386,202. So notice the population is much bigger than the number of hotels. It says in tourists, how many people, not counting the visitors, just their population, do they have per hotel? So we're doing the people over the hotel number. So we have 386,202. That's people. So this is not per capita because we're not dividing by the people. And then we're dividing that by how many hotels they have in the town. So we'll need to do that on our calculators off to the side. So 386,202 divided by 298. That's going to be, and we're rounding to the nearest whole number. I'm going to go ahead and write out what I had above it. It's 1295.9798 dot, dot, dot. It keeps going. So if we're rounding to the nearest whole, that'd be 1296. And that would be people per hotel for our units. So 1,296. Okay, well, now we're on the back side. This is just using more of our proportions that we learned about in class. Proportion, remember, is A over B equals C over D, and then you can cross multiply and solve. So notice this one says in 2021, there were 6,497 licensed Starbucks locations in the US. The population in the US in that same time was 332.9 million. What was the rate of Starbucks locations per 100,000? So we're scaling down. We know how many Starbucks there are for all of the US population. We want to kind of imagine what if we had a town of or a city of 100,000 people, roughly how many Starbucks would be there? So notice I've labeled my kind of spots. This is total US Starbucks locations, total US population. So these are the total numbers for the whole United States. Then we know we want to do just 100,000 people in the US. So notice that's on the same row as the population for total population, because this is people. And this row up here is Starbucks. Okay. And this is total population. And this is for a smaller scale. Okay. So notice I've set everything up. So I've got my 6,497 over the population of the whole US equals how many Starbucks over just 100,000. So we're cross multiplying. So we do the 6,497 times the 100,000. So I've written that down. Notice it's in parentheses. If I'm going to type this all into my calculator, I want to also make sure I put a big parentheses across the whole top. We're dividing that by the number when we get this, because when we multiply this, so just to remind you, when you cross multiply, you have one side where you have the times by x. That side is the side we always take and divide to the other side. So I didn't show that step here. I'm writing it in right now, but we're dividing this over to here. Okay, that's what we're doing. So that's where I get this 332.9 times 10 to the sixth. Again, if you're going to type that all into your calculator at one time, which you should because you don't want to round too early, you're going to put a parentheses around that whole denominator. So this is what our x should equal. Now, when I worked that out on my calculator, I got roughly 1.95 Starbucks locations. So about two Starbucks locations for every 100,000 people in the US. That's the kind of average. If you have a city with around 100,000 people in it, you should expect to possibly have two Starbucks locations. Okay, we've got two more and then we'll be done with this video. New York has 215 state parks. The population in New York is 19.45 million. How many state parks per 100,000 people are there? Okay, so we have New York totals, and then we're going to have a scaled down smaller version. You can say smaller or scaled down, scaled up, whichever way you're going. But we're going from 19.45 million people. We wanted to go down to 100,000. So we're going to have our state parks and we're going to have our people. Okay. So we know there's 215 total state parks in all of New York. And then there is 19.45. And then again, I like to use the 10 to the 6 for the word million because you do need to include that. This is not just 19.45 people. And then we're going to be solving for how many state parks are there if we had 100,000 people. Okay, so if I cross multiply on my calculator in a minute, I'll have to type in 215 times 100,000. I'm going to put all that in parentheses, and then we're going to be dividing by the one across from x. So you can already jump to this step after you've done this enough and you feel comfortable. So this will be dividing by the 19.45 times 10 to the 6. And notice I'm putting that whole part in a parentheses as well. So when I work this out on my calculator, let's see what we get. This is going to be roughly, and they wanted us to the nearest hundredth. So that's two decimal places, 1.11. So that would be state parks per 100,000 people. So that's the answer for that part, 1.11. It was 1.105. So that's why I rounded up to 1.11. Okay, let's do another one. There were 249 motor vehicle fatalities in Connecticut in 2019. The population in Connecticut in that year was roughly 3.565 million. How many motor vehicle fatalities were there per 100,000 people? So again, we're just scaling down. So we have Connecticut, and we have the scaled down version for Connecticut. We're going to have motor vehicle fatalities. I'm just going to abbreviate that. And then we're going to have the population, okay, or the people. Just labeling helps connect where you're putting things. So we had 249 motor vehicle fatalities for the whole state, and the rough population then was 3.565 times 10 to the 6, since it's a million again. We don't know how many fatalities there would be if a city only had, say, 100,000 people in Connecticut. So we're kind of averaging it out to see what that's going to be. So this is 249 times the 100,000. We're scaling it down from a big population to a smaller one proportionally. And then we're going to be dividing by the one that's across from the x. That's the scientific notation part. Put this whole top in parentheses too, just so you don't have any confusion on your calculator. When I worked that out on my calculator, I got a total of, hang on, it's still calculating. Rounding to the nearest hundredth again, about 6.98. So that would be motor vehicle fatalities per 100,000 people. So roughly what they're saying is, this big number sometimes doesn't always make sense in our brains when we look at it. We're like, well, that's a lot of population. But if you break it down to more like of a scaled down of like what's the size of a pretty medium to large city, that helps you see more what that actual could be like as a reasonable value. So I hope that helps. That's everything in 2A1. We'll be picking up on our next class at 2A2, which should go fairly quickly. 2A2 and 2A3 is pretty short. And then we'll see what we can get to because by the end of this week, I would like to, between videos and class time, get us pretty close to being perfectly caught up. All right. Have a wonderful day.